Hello and good day, pre-algebra. We are going over another type of proportion today called partitive proportions. So far we talked about direct proportions. Direct proportions are ones you're probably most familiar with. It's when something goes up, something else also goes up. Or when something goes down, something else also goes down. There's a direct relationship there between the two values. Partitive proportions, you see that word parts in there. And so what do you think we use in direct conjunction with partitive proportions? It was on your bell ringer today. What compares a part to a part? Ratios, okay? So a partitive proportion is to, I don't want to say divide a value, but we will, we'll say to divide a value, or divide a total. There we go. Divide a total into parts following, no, we're not going to use that word, just given a ratio. I like that better. Given a ratio. To divide a total into parts given a ratio. Divide a total into parts given a ratio. So this is very, very similar to what we did back in CO29 where we kind of introduced ratios. And you'll see the connection once we start to work on it a little bit. And I actually don't love the way that I explain it here in this. I think I kind of, now that we've done ratios the way I taught that, there's a more efficient way to do it. So we're going to kind of ignore what I wrote there. It is correct. It's not wrong, but there's kind of a more efficient way to do it based on what we've already talked about here, okay? So we're going to skip right down to the fun part. Divide 64 into two groups with a ratio of 1 to 3, okay? Ratio of 1 to 3. And it's not a coincidence that we're dividing into two groups, and there are two parts here, right? And later on in the third question here, you see that we're dividing something into three groups, and there are three parts there, okay? There's a direct connection there. So anyway, this is similar to the question where I gave you, think back to our ratios page where we talked about there's, 30 kids in a class and the ratio of boys to girls would be 1 to 3 or whatever it was. We figured out how many boys and how many girls are in the class, okay? That's essentially what we're doing here. So we're going to start by taking this 1 to 3 ratio and how many items are represented in a 1 to 3 ratio. We don't know if we're talking about students or volleyballs or tacos or whatever, but how many items are represented in a 1 to 3 ratio? Say it. 4, right? 1 plus 3 equals 4, okay? And so, like we did with that classroom question earlier, we're now looking at, we want to get to 64. Right? What's our scale factor? What do we have to multiply 4 by to get to 64? We have 4 items represented here, but we've got 64 total. What do we multiply 4 by to get to 64? 16. Okay? So because 4, I'm going to use a different color here. Because 4 times 16 equals 64, that's our scale factor, right? Peyton, what do you suppose we do with the 1 and the 3 now?
You need to make it to a fraction. Divide it.
Now that we found our scale factor to get from 4 to 64 is 16, we are going to apply that scale factor to both the 1 and the 3. Right? Because if we have 4 items represented here and we have to multiply by 16 to get to 64, we're going to have to multiply each of them by 16 to get 16 and 48. What is 16 plus 48?
64.
Right? It works. Okay, we've taken 64 items and we have divided them into two groups in a ratio of 1 to 3. Okay? Does that ring a bell?
Yeah.
Yeah, a little bit maybe, right? The next one, divide 600 into two groups with a ratio of 11 to 13. So we've got 11 to 13 as our given ratio. How many items are represented in this 11 to 13 ratio? How many items are represented in this 11 to 13 ratio? Nolan? 24. 11 plus 13, right? So how are we going to get from 24 to 600? What do we have to multiply 24 by to get to 600, Josie? By 25. There's our scale factor, right? 24 times 25 is 600. So now that we've identified 25 as our scale factor, what do we do with our 11 and 13? Redemption time. Peyton.
How you multiply it?
Exactly. Multiply each number in the ratio by our scale factor 25. Right? 11 times 25 is 275. 13 times 25 is 325. And it's not a coincidence that 275 plus 325 gets us to 600. Right? Okay. Okay. Next one. Divide. Oh, any questions before we go on? Okay. Divide 450 into three groups with a ratio of 4 to 5 to 6. So our process really doesn't change. Only now we've got three groups rather than two. Okay. We still have this ratio of 4, 5, and 6. How many items are represented in a 4 to 5 to 6 ratio? How many items are represented here? Scarlett, how many items are represented here in a 4 to 5 to 6 ratio? Sometimes it helps to add these things by finding tens, right? 4 and 6 make a 10. Then you got 5. What's that? 10 plus 5. You got this. 10 plus 5, right? We got the 4 and the 6. There's our 10. 15, right? So our process here doesn't really change. We're looking for the total number of items represented. And now, how do we get to 450? We find that scale factor here. What do we multiply 15 by to get to 450? Josie? 30. And now that we've identified our scale factor, what do we do with it? Landon, what do we do with it? Exactly. Multiply everything in that ratio by that scale factor of 30. You know, you can see this process is very consistent here. Okay, it's not really like solving an equations where do I add or subtract? What's the opposite operation? Do I multiply or divide? What's the opposite operation? We're kind of doing the same thing over and over and over again. Okay, we find the total number of items represented in the ratio, find that scale factor to get to our whole. 15 times 30 is 450, and then we apply that scale factor to everything in the given ratio. There are three parts to it, so all three get multiplied by 30. 4 times 30 is 120, 5 times 30 is 150, 6 times 30 is 180, and again, it's not a coincidence that 120 plus 150 plus 180 equals 450. Right? Questions on any of this? Okay, just in the next 2 minutes, less than that, 1 minute, do the next one. Divide 600 into two groups in a ratio of 10 to 20. Follow the work, follow the pattern from what we've done previously. Your given ratio is 10 to 20. Your whole is 600. Get that scale factor. Right? Get that scale factor. So if you're unsure where to start, right? We start by writing that initial ratio, 10 to 20, and finding the total number of items in that ratio. Total, we have 30. And here's where we find that scale factor now, right? What scale factor did you find to get from 30 up to 600? Landon. 20. Okay? $30 times 20 is 600. That's our whole. We found the scale factor. Multiply both 10 and 20 by 20. We get 200 to 400, which add to be 600. That's how we know that we're right. Right? Any questions on this process? Because guess what we get to practice now? Everybody flip the page. Word problems!
Oh, okay.
Yes! We can do this. Oh, hold on. Word problems! Haven't used that one yet. We can do this, okay? It says a man raised $81,000 for his son's middle and high school. For every $5 he gave to middle school, he gave $4 to high school. How much did he give to each school? Now, the difference in word problem is that you've got to set the thing up yourself, right? In the previous ones, it gave you the whole, and it gave you the ratio very explicitly, okay? In this case, you got to pull the information out. What's the ratio? Again, what a ratio compares is a part to a part. Let's read it again. A man raised $81,000 for his son's middle school and high school. That $81,000 seems pretty important. Would the $81,000 be a ratio? Is it a part? Or is it a total? Total. Okay? So we're going to just total, right? And then for every $5 he gave to the middle school, he gave $4 to the high school. What's significant about the $5 and the $4? There's the ratio, right? The part he gave to the middle school and the part he gave the high school. For every $5, he gave 4. He gave another 5, give another 4, give another 5, and so on and so forth. Okay? So our ratio is right here. 5 to 4. And now that we've got this, we've got the ratio, we've got the total, it's exactly like what you did on the front side. How many dollars are represented in this ratio? 9, right? 5 plus 4. Okay? What's our scale factor from getting to $9 up to $81,000? 9,000. And once you find that scale factor, that's what's applied to every part in the ratio. 5 times 9,000, 4 times 9,000. He gave $45,000 to the middle school and $36,000 to the high school. For a total, if you add 45,000 and 36,000, you'll get $81,000. Right? So once you set up the ratio, everything else is the same as the front side. The next one's actually pretty straightforward. In an orchard of 2,000 trees, there are peach, apple, and pear trees planted in the ratio of 5 to 3 to 2. How many trees of each kind are there? Why in business, say this is a orchard for profit here, like they sell their fruit or sell their trees or whatever. Why would you want to, if you've got room for 2,000 trees, why would you want to divide them up in a ratio such as 5 to 3 to 2? I mean, wouldn't you automatically think, well, I'm going to just plant the same number of trees for each type of fruit? Why would you might consider planting more peach trees than apple trees or pear trees? Any thoughts? When you go to the candy store or Target or wherever you shop and you go to that candy aisle, okay, you ever notice how they're always out of like Snickers or Reese's sense. Reese's. There's always so many Mounds bars. You know what Mounds bars are? They're it's coconut covered in chocolate. Ugh. Right? Ugh. Okay? Stores order a lot more Snickers and Reese's than they do Mounds because people buy those, right? If you're in business selling this fruit or selling trees or whatever, if your stats, if your data says, hey, I sell a lot more peaches than I do pears, you're going to want to plant a lot more peach trees than you do pear trees, right? If the demand is for peaches and not so much demand for pears, but you plant as many peach trees as you do pear trees, you're going to throw away a lot of pears because you don't sell them, and you're going to be always out of peaches. You won't have the product for the customer. Okay, a lot of this math that we're doing is very applicable to like business. Okay, and so how many of each kind of trees are there? That's what you were solving here. This one's pretty straightforward. Chris, Tamara, and Grace sent a package that costs $124.20 in shipping. If Chris's part of the shipment weighed 5 pounds, Tamara's weight weighed 3 pounds, and Grace's weighed 12 pounds, how much should each pay if they want to spread out the total cost fairly? If you have 3 people sending a package and everyone's sending different things and different weights, do you think Tamara's going to say it's very fair that she pays the same as Grace? No. Right? Her part of the package weighs a lot more. She should pay more. Okay, when you get to be in high school, college, and you go out to dinner with your friends, if you order a basket of fries and your buddy orders 3 burgers, 2 things of chicken strips, and a dessert, do you think you should split the bill evenly? No, you pay for what you ordered, right? You can do this with partitive proportions. Okay? Same thing here with Andrew, Andy, and Drew with investment here, the ratio, the total, and then some financial responsibility. You decide for every $100 that you make, you're going to split it up evenly, or not evenly, but proportionally into different accounts and go from there. So, I'm out of time. Homework for tomorrow is the rest of the objective. That's how you act.